Okay, I'd like to do page 288, problem E6. And for this problem, if you look at it, I assigned E5, so E6 is very similar. It just has this symbol. Remember, that symbol means prove. And it means prove with no assumptions, because there's nothing to the left of the symbol, this formula. Well, that means that this is a validity. It's something that is always true. So we will we'll have to prove this with no base assumptions. That doesn't mean we won't make any assumptions in the proof, but it means that we won't have any on the outer level. So we'll have some subproofs with assumptions, and from there we'll get it. Now, if you read through the book or watched the video I made, you'll see a trick that'll let us get something implies something pretty easily, and that's how I'm going to start this. Now, the idea will be I want to first get like Q of A implies Q of A, and we see in the book how to do that, and then from there apply the quantifier rules to it. So I'm going to start a subproof, and my subproof is going to assume I don't know, Q of A, let's say. So that's my assumption of my subproof. Now, by the repetition rule, I can repeat Q of A again, and then by implies introduction, I can get this rule here. So let me remind you of that rule. So implies introduction, that says, where is it? Here it is. Conditional introduction. If I have a subproof starting at A and ending at B, I can conclude from that A implies B. Well, that's what I have here, right? I have some subproof starting with Q of A, ending with Q of A through some rule, and I got this nice tautology out of it. That could be a problem where you're proving a tautology earlier in the class, for example. Now, at this point, looking at where I want to go, I want to get there exists X on the Q of X. There's no problem whatsoever when using an existential introduction by where you replace one of them but not the other. No problem at all. So I can do that, no issue. That's existential introduction on line 3. So if you recall, existential introduction, that's elimination, universal introduction, existential introduction. Here's how I write it, and this notation they explicitly define right above, saying you can replace some or all of the named constant with the variable. So what we did is we replaced only the second named constant A with the variable X, but we left the first one there. So what remains to show in this problem is we need to get the universal quantifier on the outside. So we need to get the for all y on the outside of this thing. And that would mean we have to take this sentence and universally quantify over the variable A. Are we allowed to do that? Well, let's look at the rule and make sure. Universal introduction, that's this section. And here's the rule. So it says you can replace the named constants, all of them, with a variable. So that's one difference between your existential introduction, where you could replace some of them but not all of them. Universal, you must replace all of them. And the you must not have that variable in there already. Okay, fine. But the important part is that that constant must not occur in an undischarged assumption. Now, that variable does occur in an assumption, the assumption of that subproof, but by the line 3, we've discharged that assumption. That subproof goes away. So that A is now lingering as a piece of residue from a now discharged assumption. So we are free and welcome to universally quantify over that A, and that's exactly what we will do. Now, the second rule here says the variable we pick in our universal quantification must not be a variable in here. Now, there already is a variable called X there, so we have to pick another variable name. And the book told us what they wanted us to prove, so we end up with this Q of y implies q of x. And that's for all introduction on 4. And that's all there is to E6.